Say you have a circle and you divide the circle into two parts with a line. This line is called a chord. Now the smaller part of the circle is known as the minor segment. The bigger part will be the major segment. But if you divide the circle like a pizza, like this, where this is the origin, the center of the circle, this small part and the big part will be called sectors. So the smaller slice will be the minor sector, and the larger part, the rest of the pizza, will be called the major sector. So the length of the circle outside is known as the circumference, but part of the circumference, for example, this part that encircles the major sector, is known as an arc. So the most important, I'm going to write it down. So the most important part of this topic is to realize that for any circle, the arc length will be proportional to the angle inside. The angle here will be proportional to the arc length here. So the arc length is equals to this angle divided by 360 degrees multiplied by the circumference, which for any circle, the circumference is always 2 pi r, where r stands for the radius. So let's see how we can make use of this. Let's see how we can make use of this simple fact to solve some problems. So in the figure, they want you to find the length here, PQ. So you have OQ, which is the radius. This is 35. OP must be also 35. And in order to find PQ, all you have to do is to find RQ. If you can find RQ, PQ is just 2 times of RQ, because this shape has 2 pieces of the same smaller triangle. But you know trigonometry, so you have one angle, you have the hypotenuse, you can find RQ, or if you want, you can find OR. So cosine of RQO is equals to RQ over OQ. Let's put in the numbers. Cosine 36 degrees is equals to RQ over 35. RQ is just 35 times cosine of 36 degrees, and this will give you 28.32 cm for significant figures. So as usual, if you want your final answer to be in 3 significant figures, the preceding steps need to be in 4 significant figures or more, 1 or more. So part 1, PQ is simply 2 times RQ, and this will give you 56.6 cm. Alright, for part 2, find the perimeter of the shaded region. So you need to find PBQ plus PAQ. Well, you can find PBQ easily because PBQ is a circle with PQ its diameter. So you can easily use the formula of a circle to find the outer arc. So now let's try to find PAQ, the smaller arc. So to do that, if you remember previously, I mentioned that the most important thing of this chapter is to realize that this arc is proportional to the angle here, POQ. So let's see what is POQ. POQ is equals to 180 degrees minus 2 times 36 degrees, because this is a triangle by itself, OPQ. So all triangles have the internal angles add up to be 160. So this angle will be 180 minus 36 minus 36. So this is equals to 108 degrees. And the arc here is simply just 108 over 360 times the circumference of this circle. So let's do this. PAQ is equals to the circumference, 2 pi r, multiplied by 108 over 360. And plugging in the numbers will give you 2 pi r, which is 35 here, multiplied by 108 over 360, and this is 65.97 cm. Again, 4 significant figures. So let's move on. We have PAQ here. Now let's move on to find the arc, the larger arc. So PBQ is simply 2 pi r2. Here, this one, this is r2, because this is the radius of this circle, which is different from the radius of PAB. So 2 pi r2 multiplied by 0.5, you will get PBQ, because this is a semicircle, which is half. So plug in the numbers again. 2 pi r, 28.32. We get this number from here, the previous question. Multiply by 0.5, and we have 88.97 cm. So finally, the perimeter is simply 65.97 plus 88.97 cm, which is 155 cm. 3 significant figures. Let's look at another example. In this figure, O is the center as usual, radius 8 meters, point R and P falls on the circumference of the green circle. So given the angle inside, find PQR. So PQR is made of 3 lines: the straight line PQ, the straight line RQ, and the curved line RP. So let's see how we can find these 3 sides. So first off, let's find the length of the arc RP. So length of arc RP, using the property that I mentioned, the ratio, 36.9 degrees over 360 multiplied by the circumference of the circle, 2 pi r, 8 meters. Punch your calculator, and you will have 5.152 meters. So 4 significant figures. So we found the curve RP, or the arc RP. Let's find the straight line RQ. Now you have ORQ, which is a triangle, so you can make use of the trigonometric properties to find the length of RQ. Tangent of 36.9 degrees is equals to opposite side, RQ, over the adjacent side, which is OR. So we can solve for RQ immediately. 6.007 meters. Alright, 2 down, 1 more to go. So to find PQ, we will have to find OP, and then we will have to subtract OP from OQ. Now OP is simply 8 meters because that is the radius of the circle. So let's find OQ, which shouldn't be a problem because OQ is the hypotenuse of this triangle, ORQ. You can either use your trigonometric properties, sine or cosine, to find OQ, or if you want, you can make use of Pythagoras theorem. Let's use Pythagoras theorem. Alright, and we know that the sum of the square of the two shorter sides. So 8 square plus 6.007 square RQ will give us the hypotenuse squared, OQ squared. So OQ will be simply just 10.00. That's 4 significant figures. Alright, so you have all three sides. All you have to do is to sum them to find PQR. So PQR is 5.152 plus 6.007 plus 10.00, and your answer will be 13.2 meters.